here, in this case, you are having total loss. For this loss, one value is missing. Okay, remove this value. Now, after removing this value, till how many values you are having? 9 values are there with you. Now, for this 9 values, just you calculate the median. How you are going to calculate the median for these 9 values? For these 9 values, just you are going to apply the sorting technique. And if what is there in the center position in the 5th value? So let us apply the sorting technique for this. Go ahead and apply the sorting technique. What would be the starting value? This is the first one. And second one will be 309 to next 3, next 4. This is 5. So 5th position, this is the median value. That is the reason it has got as the median value as this one. 0.874. Right? So just it is going to apply the same concept. That is the backend code. Right? So now what are the median value you have got? You want to replace this median value, right? 0.874. If you want to write the value, write the value. No, sir, I want to use the variable name. Anyways, I have stored in the variable now. I want to use the variable name, write the variable name. This variable name is equal to this one now. You can copy even this one also directly here itself. Copy this one itself here. In one line, you will complete everything. So how it is going to work now? First it is going to calculate the median. That median value will be filled in this and it is going to replace in the original. For this code, what is the backend process? First median will be calculated. First step, median calculation. Second step, it is going to fill. Third step, after filling again it is going to store in the original data frame. Stores in the original. Store in original. These are the 3 steps are involved within this one line of code. Okay, you don't need to write even this one. Directly you write this one. Only one single line if you write also, directly it will calculate the median and it will fill in that column. Everything will be completed in one shot. And if you open DF, see that missing value has been replaced. This one more value have got like this. The missing value has been replaced with the median value. Similarly, mode. You are going to calculate the mode. If you have stored in a variable name, variable name. Value value. Directly formula formula. Whichever you want, you can write here. Right? Once you are going to write the mode, it is going to fill. So this fill NA is the option within the pandas. So now we are having one more library called as sklearn. So once again, I'm going to, in real life, we are not going to write this many lines of code. First step, I'm going to load the data and I'm going to check whether they are missing values or not. Directly, I'm going to use the fill_mean median mode like this. In one shot, I'll complete. For your explanation purpose, I'm writing these many lines of code. These many lines of code I'm writing and I'm showing you detailedly everything one by one. That is explanation. In tomorrow company, you are not going to explain to any others. You are not the trainer, they are not the students. Then there is no explanation is required. Direct implementation is required. So directly you are going to write in one line only everything. This column fill NA with mean. This column fill with median. This column fill with mode. Everything will be completed. In one shot, cleaning will be completed. Cleaning the missing values will be completed. Right? Is it clear? After writing, again checking, cross-verifying, all these things, when we are going to do one explanation, when I am explaining, I have to explain very clearly. When you are practicing, you have to do very clearly. At the time also, you have to practice in this way, not in this way. You should not go in this way. As a trainer, I can start like this and I can explain directly this one only, right? Why I have explained above one? I can explain directly this one only, right? First, this is the first line. In the first line, this is going to calculate and it is going to replace. I can explain directly this one and you will also understand. But why I have explained those many lines above? Because clear explanation. What is the backend code of that? How it is working? When the backend code and whenever it is understanding clearly the concepts, these things will be easy. Otherwise, you have to by heart these things. You will fill this then as the one of the code and you will by heart. Right? Is that clear? Next one is second option I'm having by using the sklearn library. sklearn. S stands for scientific. K stands for kit. Scientific kit learning. sklearn full form is scientific kit learning. In shortcut, we used to call it as sklearn. Some people will call this one as scikit-learn. Scikit. learn. Scikit-learn or sklearn both are same. Still more shortcut is sklearn. Full form is scientific learning. Is the full form. Okay. Now here I'm going to use sklearn library. Now using the sklearn library also you can work. So before sklearn library, how you have filled the values? Let us see how you have filled the values before sklearn is. You have filled the insurance, whichever the missing values are there. These two missing values you have filled with the mode, which is 1. You have filled the missing value of this one by using the mean, which is 30.22. So for the age column, you applied the mean concept, and which is the answer of 30.22, and you have filled the record. Similarly, for the loss column, you have applied the median application, and you have got an answer of 0.874, and you have filled this one. Similarly, for insurance column, you have applied the mode concept, and you have filled, and the answer is 1. With 1, you have filled these two values. This is the one which you have done in the pandas. Same thing as it is. Once again, I'm going to calculate the mean. Again, I'm going to fill, and this time I'm going to work on the sklearn. Sir, which one we have to do in the real time? Again, this question. Two options you are saying. Option 1 is with respect to pandas, and option 2 is sklearn. Which one we have to apply in the real time? Which one you feel easy? That one. Because both are same. Both are going to be filled the same values. Everything is same. Then why you are showing two options? If both are same, why you are showing two options? The first option is all. The first option, whatever I have shown you, the fill NA is there, na pandas. Using the pandas, the fill NA, that is the easiest one. Okay. What are we are going to see now from the sklearn? This is somewhat difficult one when compared to this. Comparatively, it is going to be difficult. Okay. Now I am going to explain the difficult one. Now, anyways, anything is same. You told that anything is same. Then easiest one we can continue. Na? Why you are showing the difficult one now? What is the use of showing the difficult one? Because if I don't show the difficult one, what you are going to see in some textbooks, or in some YouTube channel, they'll explain the second option. What you will think at that time? What is your inner feeling? My sir has skipped this one. My sir has not explained this one. You'll have that inner feeling. Whether you'll get that feeling of sir has told the easiest one, whether you'll get that feeling, or whether you'll get that feeling of sir has skipped off. Which type of feeling you'll get? Don't say outside with respect to normal one. Say me exactly what is the inner one. That one, right? So that is the reason I'm showing the two options for you. First time if I show you all the options, one time or second, 2 times or 3 times if I show all the options, and later if I show only the easiest option, then you realize, okay, sir has shown us only the easiest options. Then you realize that like this. Otherwise, you will think that sir has done with respect to like this. Okay. So if you feel the confused between this one and this one, if you feel confused, means don't listen this one. For you, it is out of coverage area. Don't listen. Whoever the confusing people is there in the class, don't listen to this topic now. Okay. This is not for you. Just leave it. If you are okay, sir, let us see what happened. Let us see the one more way also, miss, you can listen. It is of your choice. Now df is equal to pd.read_csv, and here I am going to have with respect to, once again I am going to load again 2 missing values, 1 and 1 missing values are there. From sklearn there is import the simple imputer. This is the function. Simple imputer is the function which is available from the sklearn. So from the sklearn I am going to import this particular function. Okay, and this function here there is a 3 steps are involved. Whenever you are going to work on the sklearn, 3 steps are involved. The first step is import. Import whatever you want. Whether it is a machine learning algorithm also, whether it is this one also, anything, 3 steps are common. First one is import. First step is import whatever the function or whatever the machine learning algorithm, whatever it is, just import that function. Second step is save this one. Save into some variable name. The function you save it as a variable name. Save into some variable name, into a variable name. This is your second step. The third step, you are going to apply the fit_transform. Apply fit_transform. What is meant by fit_transform is, fit means calculate. Transform is apply. Fit underscore transform is fit means calculate. Transform is apply that one. Whatever you have calculated, apply that one. Is called as fit underscore transform. So here, let us observe these 3 steps. First, I am going to, from sklearn.impute, I am going to import the simple imputer. Step 1. Now, simple imputer, where the strategy is equal to mean. This is the argument. Okay, argument strategy is equal to mean. Now, it is going to be as the mean imputer. I am going to save it as a mean imputer. Now, what I am going to do is, third step. What is the third step I have told you? Fit and transform. Whatever the function you have done, you just apply the fit and transform. So what it is going to do is, it is going to first calculate for the loss function, what is the mean value. We are applying for the age now. Let us go with age. CLMAG. CLMAGE. So what it is going to do is, first it is going to calculate the, for CLMAG, that is for this column, it is going to calculate the mean imputer. Mean imputer will be calculated. What is there in the mean imputer? Strategy is equal to mean. So it is going to calculate the mean value. First it is going to calculate the mean value. Transform is, after calculating, it is going to apply that mean value. It is going to do like this. See? Got the point? Is that clear? Fit and transform is just calculate and apply. It is calculated and it is applying on that and it is filling that value. Simple imputer means, impute means replace. Impute means replace. Is called as impute. Impute means nothing but replace. Imputation techniques means replacing techniques. Okay. Simple imputer means very simple. Simple function. It is very simple function. Okay. The person who has created from sklearn impute, he can simply write import imputer. He can create the function, but he has created simple imputer. That is the name he has created. If I have created means I used to write the name as SRK imputer. The person who has created, their name is that one. That is their name. That is inbuilt functions. So here the simple imputer strategy is equal to mean and you are going to save in the mean imputer and you are going to apply the fit and transform. Now whatever the output you have got is an array. This function will return the output as array. Now this array you want to convert as data frame is how to convert? Just apply the pd.data frame. That's it. pd.data frame. That is the reason in the pandas I have shown you how to convert an array to a data frame. So now just I'm converted. Data frame has converted. Earlier it is an array. Now it is a data frame. Now this data frame you want to replace in the original of the value. So directly you are going to take like this. df of CLMH is equal to df of this CLMH. Now what happens? Now if you are going and open the df, now if you check the df, see, df has been replaced. First, this right side part is executed, everything is converted and data frame is converted. First, mean imputer will be taken. This age column, mean value will be calculated. After calculation, the mean value, it is going to fill that value. After filling that value, it is converted to data frame. After converting to data frame, now whatever the original data frame is that original data frame is going to be stored as in the df like this. Pandas is a mutable object or immutable object? Pandas. Mutable object, right? Pandas is a mutable object. Why? Because it is also built over the list and dictionaries. Simple. How to create a new column in pandas? Just you are going to write df of column name and right side you are going to write the values. So values are ready. You are writing the column name and a new column will be created like this. But this new column is already having the same value. Now when in the dictionary, if two keys can be same, two can be the same keys, automatically it is going to replace now. The same thing was done here. Simple. Pandas was built over the dictionary only, right? That's it. So what are the 3 steps? First one is you are going to do the import. Second one is you are going to take the function and you are going to save that one. And in the third step, you are going to apply the fit and transform. These are the 3 steps. This step I have explained very clearly. And that too I have told you, first inner brackets will be completed. See, this is the inner bracket. Inner bracket means this column will be extracted first. After this column, the inner bracket, that is fit and transform, will be applied. After that, data frame will be converted. Inner brackets will be completed first. After every inner bracket completed, left side part is completed. Now right side part will be executed. Is that clear? So total 3 lines of code. Now same 30.22. Above also the same thing, right? 30.22. Whatever the first we have done in this this one, that is same 30.22 and the same. Here null values are there, here 2 null values are there. Now also if you observe here also we are having the same way. 1 null value, here 2 null values. What is the difference between these two then? Nothing difference. That is also same, this is also same. It is going to change only this value. Right? Is that clear? Whereas this one you have to write in 3 lines of code, whereas that one you have to write in 1 line of code, only fill and name. Second one, similarly, median imputer. Simply imputer stat g is equal to median. This time you don't need to import. Already you have imported. Na? One time imported done is no need of. Simply imputer stat g is equal to, you have to write the median. And you are going to take this one loss. You are going to fill with loss. And you are going to take the loss. First you are going to calculate the loss median value and it is going to be filled. And if you open the DF, see the value will be filled with 0.874. Same way. Similarly, mode imputer. Simple imputer stat g is equal to most frequent. You can't use the word of mode. Most frequent. Okay, most frequent. Again you are going to calculate. Again you are going to fill. Now this value is also replaced with 1 and 1. And finally, all the missing values has been cleared off. There is no missing values. 3 columns are there, 3 columns has been filled off. One way is using the pandas fill and a. One way is from sklearn using the simple imputer. Using these 2 techniques, you can fill the missing values. Which technique means whichever you feel easy, that is the easiest technique. Clear? Is that okay? Now, next we'll go to the next concept with respect to future transformations. Okay, for future transformations, we have to go with sklearn only. Only option is sklearn. So here, transformations are nothing but if you are having a skewed distribution, whether it is a left skewed or right skewed, you have to convert to normal distribution. Sir, why I have to convert to normal distribution? If I keep the skewed distribution directly in my data set, directly, whatever the data they have given to me, the data directly I go and I'll apply to the machine learning. Without doing anything, I'll directly go and copy paste into the machine learning. Obviously, results will be very bad. Why? Because every machine learning algorithm was designed based on the normal distribution, assuming the data is normal. They have designed based on the normal distribution. That is their basic assumption. Okay, it is a normal distribution. And based on that only everything they have created. Now here, if you are having a right skewed distribution, you have to convert to normal. If you have a left skewed also, you have to convert to normal. Any distribution you have to convert to normal. How to convert normal means right skewed distributions you are going to apply the nth root of that for that particular column. For example, 1, 4, 9, 16, 25. This is the some column name. X is the column name. For this, you are going to apply the square root. Now the next column you are going to create a square root of X is the new column you are going to create. What is that? 1, 2, 3, 4, 5. Just you are going to create the, with respect to the square root, one more column you are going to create, a new column. And you are going to check the skewness of this column and skewness of this column. Before to this is the original data. After modification, this is the data. From where you got these values? From this one only, right? So this is the data was created from this. This is the original data. You are going to check the skewness value from this and you are going to check the skewness value of this. The skewness is going to reduce by applying the root transformation. If it is a right skew distribution, for right skew distribution, you have to apply the nth root or log x. Sir, nth root, what is this n value? I also don't know. If I know that a value has 2 means, I'll write 2 only, right? Why I'll write n? 2 root or 3 root, we'll write directly. If the n value is fixed, means directly we'll write that number only. Na? Since we don't know that number, we are writing n. Then how to identify which value of n? Whenever you don't know any value in the entire data science, we are going to try with multiple values, different values, right? So here for left skewed, you are going to apply the nth power or exponential. So like this, by writing like this, you are going to convert the data to normal distribution, skewed distribution to normal distribution. So just import NumPy as NP, pandas as PD. And I'm going to take a data set called as Titanic data set. Okay, Titanic means Titanic movie. Everyone has watched Titanic movie, right? So in the Titanic, with respect to number of passengers are there and the passenger IDs, whether they have survived. So many, some of them has been died and some of them has been survived. So survived. There is a P class. What is meant by P class? Means passenger class. Whether there is a first class ticket or second class ticket or third class ticket. And the name of the person and the age, that is gender and the age. SIB, SP means siblings or spouse. Means they are having any siblings or they are having any wife in that ship. If one is there, means either some sibling is there, maybe brother or sister, whatever it is, or some wife might be there. Similarly, PARCH means with respect to parents or children. PAR stands for parents or children. Whether this person is having their parents in the ship means no. Children are there means no. 0. What is the ticket? PNR number. And the ticket fare. And what is the cabin they have allotted? Missing value. Cabin number. And embark means what is the station they have boarded that particular Titanic. Okay. S stands for Southampton. So there is one city name with respect to where they have boarded this Titanic. Now we are having, this is the data set. Out of which data set I am going to use only with respect to use columns is equal to pair. Only pair column I am going to select. Means remaining data I am not going to select. While writing the read underscore CSV, till now I have shown you how to read the CSV file. In the last class I have shown you how to read the CSV file. Now there is one more keyword. Use columns. Use columns means these columns only will be imported. Other columns will not be imported. List of columns. You can write whatever the list of columns are there. Only those list of columns will be imported. Other columns will not be imported also. So I am going to import only the fair column. Sir, why you are importing the fair column? Because this is a numeric data. I am going to show you how to convert this column to a normal distribution. If it is a skewed means how to convert. So first what I am going to do is, first I am going to calculate dot skew. I am going to apply for this data frame and the column name. Data frame column name means that particular column will be called. And I am asking the skewness value. What is the skewness value? It is going to say 4.78 is the skewness value. If the skewness value is 0, it is called as perfect normal distribution. Perfect normal distribution. If the skewness value is less than -1, it is called as negative skewed. Negative skewed, or it is also called as left skewed. If the skewness value is greater than +1, it is called as positive skewed or right skewed. Positive skewed or right skewed. If the skewness value is greater than +1, and if the data value is from -1 to +1, less than -1 I have told as negative, +1 means I have told as positive. If from -1 to +1 is there, then it is said to be a normal distribution. So if plus or minus 1, we used to call as normal distribution. We are not going to consider as that much of skewness is there. If it is more than +1 means, then only we'll feel as it is a skewed distribution. If it is less than -1 means, we'll feel. No, sir, I will think even 0.5 also some skewness is there. Still, I want to convert also, you can convert as per your choice. Okay. Generally, +or-1 is considered as a normal distribution. If the skewness value lies between +or-1, it is considered as normal distribution. Okay. Sir, how we can know this is a skewed column or not? You are going to check for each and every column. If multiple columns are there, you are going to check for each and every column. In the data set, you are going to have, for example, like this, a data set is there. First column, second column, third column, fourth column, fifth column. How many continuous variables are there in this? First, you have to identify. This is a continuous variable, assume, and this is also a continuous variable. For both of them, you have to calculate separately. Everything you have to do. Sir, like this, for example, 100 columns are there. How I can do? First, you have to take the entire list of columns into a list and apply the for loop. Right? Apply the for loop of one after one after one. One column after one column, it is going to calculate. Is that clear? So first you are going to take one of the column and you are going to check the skewness. Now it is 4.78. Now it is skewed distribution or non-skewed. Skewed. Whether it is a positive or negative. Positive. Because the value is positive skewed, which is also called as right skewed. For the right skewed, you have to apply either log or nth root transformation. Nth root means either with respect to square root or cube root or fourth root or fifth root, sixth root, seventh root, like this. Which root I have to apply? Let us try with one by one. First, let us try with data fair column I am going to select, and to the power of A is given by double star exponent to the power of 1 by 2. What is meant by 1 by 2? Square root. X to the power of 1 by 2. Square root you are going to write like this. Cube root. How you are going to write cube root? X to the power of 1 by 3. Right? Let us try with first one with square root. Let us try with square root. And after applying the square root, now check the skewness value. It has been reduced. But still it is a skewed only. Let us increase this one to 3. Let us try to 3. Still it has been decreased. Let us increase 4. Still it has decreased. So now it is almost normal. Now we can stop here itself, or no sir, I want exactly 0. Till that I want to go. Try 5. With 5, again you are going to get minus 0.21. Now with 0, whether minus 0.21 is close or 0.5 plus 0. Is very close. Minus 0.21. Because the closeness you are going to observe, whether it is a positive or negative, the value only you are going to see. Okay. So minus 0.21. Okay. Almost close you have got. Like this, you are going to try with respect to different values, and finally you are going to convert. Now, whichever the value you have got, this value, after converting, this value you are going to replace in the original one. This is called as data transformation technique. Right? Now now the machine algorithms earlier, if you give the same data for the machine and if you ask the accuracy means, it is going to have less accuracy. Now after converting like this, and if you give this data, if you substitute there, now it is going to give the better accuracy. The accuracy increases of the machine learning algorithm. Why miss? Because the machine learning algorithms are designed based on the assuming the data is normal. If you have given perfect normal distribution means, the more accuracy you will get. This is a root transformation. See, I have applied the root. I also don't know. First I have tried with you in front of you only, right? With 2, with 3, with 4, like this. I have tried with multiple values. So let us, once again, I am going to try with multiple values. Sir, if I increase to 6, might be decreased now. Who knows? Let us try for 6 also. And let us see this one. Why to write in 2 differences, write in the same cell. 0.95 means suddenly increased. For 5, it is minus 0.2 means now for 6, it is minus 0.5. It has been increased. So 5 is better. Out of all of them till now, out of 2, 3, 4, 5, 5 is better. Now your answer is between 4 and 5. So try with maybe 4.5. 4.9 or something like this. Let us try even 4.9 also. 4.9. Let us try with this 4.9. Sorry. Oh, okay. Here. So your miss, it has been decreased. Oh, nice. So let us try with 4.8. Let us try with 4.8. Okay, still it has decreased. Nice. Let us try with 4.7. Oh, still it has decreased. Let us try with 4.6. I again increased. Miss, between 4.7 and 4.8, some value is there. Try with 4.71. Okay, 4.72. Like this, you are going to try, and you are going to get to the 0. When the value is unknown, we have to try in this way. Now the same try, whatever I have done is manual. Na? The same thing I want with respect to the code means for loop. For I in range of from here to here. For each and every individual value, it will apply and it will try. And which is the best value, it is going to give me the output. What I am going to do? First, I am going to take between 2 to 20 with an increment of 0.001. Some list of values I am going to take. Now for every value, for I in these values, for I in given list, whatever the list is there, for I in list, I am going to apply. And I am going to apply this concept. This value will be replaced with I to the power of 1 by I. It will be replaced with I. So it is going to try with one value, second value, third value, like this. It is going to try. And I am going to store it in an empty list. And I am going to save it as some list as S is equal to something. Now, whatever the list I have got, in the list dot sort, I am going to apply. By default, ascending order is going to get now, which is having the least value, S value. That value I am going to select. Simple. Right? Is that clear? If you want to apply the for loop, means for loop, manual. Whatever I have done manually, the same thing I am writing in the for loop only. Is that clear, guys? Sorry? X dot min also directly. S dot min. Exactly. That is best. Even you don't need to go with the sort also. Directly you can take the S dot min. But min function is not applicable for the list. Na? Again, you have to convert that list to array. Then you have to apply the min. That list, whatever the S is there, na, S is equal to list is there, na, that you have to convert to array. np dot array of S. Now, whatever this value, again, you are going to store in a variable B. Now, for B, you can apply the min. Because this min is the attribute one for numpy array or for this one. This attribute is not available for the list. Is that clear? That is again universal function that you can go. Dot list you can't apply. If you want to apply the log fare, how you are going to apply the log? Just np.log of. You are going to take the variable np.log of. Why you have taken the +1 inside that one? Because in the fare, the minimum value is 0 is there. One of the values 0 is there. Whenever the value is 0 is there, automatically if I apply the log, it is going to be infinite. So what I am going to do is first I am going to convert every value +1. After doing +1, for that I am going to apply the log. And I am going to check if I apply the log distribution. If I apply the log, let us see what happens if I apply the log. And I am seeing when compared to this, root is better. Okay. And you can even try with reciprocal. Reciprocal is also one of the function, one of the option. So 1 by data of fare. And you are going to try with this. And you are going to take for reciprocal how it has been transformed, the data. There is no difference. Because reciprocal is not going to apply for the right skew distribution. Reciprocal will be applied for the left skew. Right? Like this you are going to apply. Sir, if I want power transfer, Instead of 1 by, you are going to write power like this. Nth power means that is the meaning. Directly no need to write 1 by. That is nth power. Is that clear? If you write 1 by means it is root. If you don't write 1 by means it is with respect to power. Done. In this way, you are going to convert the data to from normal distribution, skew distribution to normal distribution. Is that clear? Sorry. Why we have taken the +1? Because one of the value is 0 is there. If you apply np dot log of that particular value, what it is going to give? Infinite value. Now, how you can calculate the skewness for infinite value? Error you are going to get. That is the reason that negative values, first whatever the 0 is there, for in order to apply the log only. Power means 0 to the power of nothing is there. Square root of 0 also not a problem. That is also not a problem. This is also not a problem. But when you are applying as a log, then it is going to lead to the, with respect to the problem. Or 1 by 0. Reciprocal also 1 by 0 if you take also infinite, there will be a problem. So since we are getting the infinite problem like this, for that reason, we are going to convert this 0 first by adding some value. So why 1 only means? That is the minimum value. So you can add even 0.0001. Some value add. So that it is not going to be infinite. As per your choice. Now if you add with respect to 0.000001, is there any change will be there in the fair? If the fair value is 12 means, now the fair value is going to be 12.000001. Is there any difference? Now 0 is there. For 0.000001 also there is been no difference. The only thing is here it is going to have log 0 as infinite. For this some value will be printed at least. It is not going to be infinite. Some value will be there. So whenever you are going with log, then make sure that 0 you are not having. The same example, whatever the np dot log I have explained in the numpy. In the numpy I have shown you np dot sine, np dot log and np dot exponent. These are the three things I have shown you in the numpy, if you remember. At that time I have told you this I am going to use later also. I ask you to make the star mark also, if possible. The reason is that np log I am going to apply here now. Data dependency. For example, ask me at the end, because ask me at the end. You know that dependency and all these things. Now you ask me at the end. Others say I'm not going to confuse. Okay. Now the last transformation we are having is called as boxcox transformation. The last transformation which we are having is boxcox transformation. What is meant by boxcox transformation is this is going to take in terms of every x value to the power of lambda divide -1 divided by lambda. Every x value to the power of lambda divided by x to the power of lambda -1 divided by lambda. Sir, what is this lambda value? It is going to try with different lambda values. So here see, from SciPy, this is available in the SciPy library. This is not available in the pandas or in terms of other libraries. It is available in the SciPy library. SciPy is nothing but scientific Python, okay, which is used for statistics purpose. From SciPy, I am going to import the stats. In the stats, there is a function called as boxcox, and for this boxcox, you are going to apply. And for this, you are going to get the lambda value of this one. Means for every x value, if you apply the -0.097 divided by -0.097, the data is going to convert to normal, it seems. So this is going to identify this particular lambda value. This function will identify the lambda value, and after doing this, it is going to convert to normal distribution. Is that clear? In this way also you can convert. One is log, one is with respect to root, exponential, power, and boxcox. Like this, you are having multiple options. Sir, for my data, which is the best one, miss? You have to try with all of them. By seeing the data itself, we can't say which is the best. Okay. So this by seeing the data, okay, go and apply this one, you will get the better answer. We can't say, no one will say like that. We have to try with the best, we have to try with all the options, and we have to make sure that finally this data has been converted to normal or not. Is that clear? Once again, boxcox. So once again, boxcox is nothing but for each and every value. See, for example, there is X values. 1, 2, 3, 4, 5. Let us assume this is skewed distribution. Now this skewed distribution has to be converted to normal distribution. So it is going to apply x to the power of lambda minus 1 divided by lambda. Some lambda value. So that lambda value, it is going to calculating by trying with different values. In the back end, it is going to try with infinite loop. For different, first it will start from 0, 0.0001, 0.02. Like this, it is going to try with multiple values. After trying with multiple values, it is going to confirm that, okay, I'm having the best value is x to the power lambda of minus 0.97. 0.097 is the best value. By substituting that value, for every x value, you are going to calculate and you are going to get each value. Now, if you check the distribution, the skewness of this one, it will be normal. Every skewed distribution will be converted to normal distribution by using boxcox. Sir, now you have shown us why I have shown you the everything by using a single column only. Everything I have taken only fair only, right? The square root, I have root transformation I have applied on the square. I have applied log also on the square, and I have applied boxcox also on the square. Everything I have applied on the square on the fair column only. On one column I have applied different techniques. Now, which is the best one? For boxcox, you have got the skewness of 0.04. For log, what is the answer for the log? You have got 0.39. For the root, you have got minus 0.0049. Now, out of these three, which is the best one? Root is the best one. So, you are going to confirm the root. You have to try with all the options. Whatever the options you are having, every option you have to try. And which is the best one you are getting, that one you have to select. If, for example, I have got here 0.00004, I have got missed, then I have to go with boxcox. Which gives the better value, that is the best one. So, which is going to give the better value, miss? Without trying, we don't know anything. Okay. Sir, like this, if you want to try for all the variables, so much of time it is going to take now. Obviously, it is going to take so much of time. Who told that by giving the data set immediately within 5 minutes, you give the answer? Is there anyone asking like that in the company? Morning 9 o'clock, they will send the file, and by 9:30, you give me the answer. Is there anyone asking like that for you? There will be much time, right? In that time, you have to do so many things, obviously. By seeing the data sets itself within second, 9 o'clock, 9:01 only, you are going to submit the project. Within 1 minute, you are going to submit the project. No, right? Why? Then why hurry? In the company, the project manager is going to use a common dialogue that I want correct answer, not the quick answer. The first day I have used it in the core Python. At the time I have told you that I want a correct answer only, don't tell me the very quick answers. In the company, the project manager or your team leaders will use the same thing. Arey Babu, take time, do the slowly, but give me correct answer only, don't go in hurry and give the worst answers. In the company, first I will submit one answer. Sorry. No. This is not right answer. I will send one more. No. Again, one more. We are not going to do like this. Whatever the answer you have submitted, this is the final submission. That submission, before submitting, you have to cross-validate yourself only. You have to check yourself only. Finally, you have to submit. After submitting, I have forgotten this to add. I'm going to submit once again. Miss? Simple. They are going to remove you. There will be only one option. You have to submit one time only. Right? So, what is meant by transformation, miss? Future transformation. What is meant by future, miss? Variables. You are going to convert the variable, continuous variable, which is from the skewed to the normal. Converting the continuous variable which is skewed distribution to normal distribution is called as transformation. Future transformation. Okay. Here you are just converting. You are converting. You are not going to manipulate, or you are not going to add the new values, or you are not going to delete the new values. Whereas data cleaning, you are adding the new values. Actually, in the original data, that values are not there. You are adding that values. Adding of values or removing the values is called as data manipulation. Adding or deleting is called as manipulation. Whereas if you are doing with respect to conversion, then it is called as data wrangling. Wrangling means conversions. Converting from one format to another format is called as data wrangling. If you add and delete means, then it is called as manipulation, because in the original data it is not there. You are adding. Right? Next one. In the data wrangling technique, the next one we are going to move on to the future scaling. Or instead of future scaling, let us move on to the, which one you want, easy one or difficult one? Anyways, we have to learn everything one by one. Okay, let us go with future scaling only. If I go with encoding means, again I have to explain two options, pandas and sklearn. Okay, so wherever the multiple options are there, I am explaining the multiple options. So if you are feeling that, sir, these many multiple options you are saying means we are confusing means, remember only one option, whichever you feel comfortable. In your brain, you remove the second part. In the interview, they are not going to ask you that whether you are going to use sklearn or this one or that one. They are going to ask only how you are going to treat the missing values. That is the theoretical question, and you have to tell the theoretical answer, not the coding answer. They are not going to ask in the how you are going to use in the pandas, what is the function name, whether you are going to use fill-na or whether you are going to use sklearn. They are not going to ask these questions. And whether this simple imperator is going to return the file as an array or as a data frame, they are not going to ask that questions. Okay. So every function was inbuilt functions. We have to check based on the help file only. So you are understanding for this function means tomorrow one more function. For that output will be in terms of directly data frame. Some functions return file is, for example, I have created like this: def add a comma b. C is equal to a plus b, return c var. This is one way. One more way, def add a comma b, c is equal to a plus b, return float of c. For example, you are using add of 1 comma 2. In this case, if you do means, you are going to get the output as 3. In this case, the function was created means you are going to get the output as 3.0. How this function was created means, how you can know that which type of function I have created. Till you open that one only, you'll know. Whether I have created this one or this one, how you can know means till you have to open. You have to open and you have to see. That will be in the written file. That will be in the documentation. In the help file, it is going to be there. Right? Is that clear? So every function you have to check in the help file, and then only will understand. So that is the reason you should not by heart the functions. Functions output you should not by heart. How to treat them you have to understand. Right? That is important. Next, future scaling. Future scaling is nothing but scaling down the data. For example, okay, I want to predict the data scientist salary. Your present, what is the salary I have to give to you? I have to predict. For that, I'm going to take out of 10 only. Entry score. Test score means entry score. Okay, entry score. Your entry score out of 10, you have got 8, 9, 7, 6, 9, 8.5, 6.5, something you are having like this. And years of experience, 0 years, 1 years, 2 years, 1.2 years, 1.3 years, something like this you are having. Now, previous salary, your previous salary. Here, experience person 0 means there will be no previous salary. It is going to be 0. Now, one year experience person is going to have the previous salary, annual salary of 6 lakhs. 2 years means he is going to have some 9 lakhs. 1.2 means he is going to have 7.2 or 7.5. Something you are having like this. Lakhs, in terms of lakhs. So now the value, whatever the value is there, this is 6 lakhs. This is 9 lakhs. This is 1 lakh, that is 7 lakhs 20,000. 7 lakhs 40,000. Something you are having like this. Now the present salary I want to estimate. Now for me, this one, everything are equal. Since here the big number is there, means I can't deviate based on that number, right? Here the number is important, or the with respect to the score, interview score is important. So like this, each of the parameters should be on the same scale. If some of the values is very high, some of the values are very low, means now there is a tendency of the machine will understand, since the big numbers are there, it will understand that this is the important column. It will understand this is the important column for predicting the answers of this one. So it should not understand like that. It has to understand everything are equally important. Means what I am going to do is I am going to scale down. Each and every column I am going to bring into the same level. It is called as feature scaling. Okay, scaling down the data. Why you are going to scale down the data? Because the machine will understand in a wrong way. Based on the higher values, it will give the more importance to the higher values. That is the reason we have to bring down. So how we are going to bring down? For example, 80 out of 100, 8 out of 10, 4 out of 5, 0.8 out of 1. Everything are same only, right? Numerator 80, 8, 4, 0.5, 8. Everything are same. Just you are scaling down that one. Okay, from 80 you are bringing to 8. Means dividing every value with 10. Our denominator and numerator you are going to divide by 10. So 80 by 100, 8 by 10, both are same. Everything are same. You are just bringing down. Instead of 80 by 100, instead of seeing as 80, you are bringing as 0.8. This 80 is for 100, 0.8 is for 1. Both are same only. But value will be reduced. Concept is same, but values will be reduced. If you give me for me the rating out of 5, 4.5 out of 5 you have given me the rating. What is the meaning of that? It is 9 out of 10, which is 90 out of 100. Everything is same. Right? Just you are going to bring down the values. Sir, anyways, everything is same now. Then what is the problem is, but machine has designed, the algorithms has been designed in such a way by taking the values. They are dependent on the values. They don't know the scenario, na? They don't know what is meant by feedback word, what is meant by age. There is a column called as age. Do you think that machine will understand age means, oh, this is the age of the person? Do you think that one? The machine knows no English language. Age means age of the person. It will not understand like that. In the age, whatever the data is there, according to the data only it will work. Okay. So since it is working on the only the data values, so we have to bring all the values to the same value. Same. So there is this future scaling importance are having the most important in some of the algorithms, like linear regression. There is one of the algorithm called as linear regression and logistic regression. There it is going to influence, highly it is going to influence. And support vector missions, K means clustering and dimension reduction. So many techniques of machine learning are there. There it is going to have the high impact. So for these things, we have to compulsory have to apply the scaling. Otherwise, you are going to get a large amount of error. Right? So what are the different types of scaling techniques are available? What are the different scaling techniques are available? Means the first scaling technique is called as standardization. Standardization means you are going to convert everything to the standard value corresponding z-score. So first values, there is with respect to 1, 2, 3, 4, 5. Each value will be converted to corresponding z-score by calculating x minus mu divided by sigma. First for this, you are going to calculate the mean value. Calculate the standard deviation value. For each and every value, 1 minus mean divided by sigma, 2 minus mean divided by sigma, 3 minus mean divided by sigma. For each and every value, minus the mean divided by sigma. This process is called as standardization. During the descriptive statistics, I told you, converting of each of the value to corresponding z-score is called as standardization. And the data, whatever the distribution is there, this is called as standard normal distribution. Is that clear? So let us try. And this is also applied only on continuous data, not on the discrete data. Transformations, that is earlier whatever we have done, that is also continuous data, and this is also for continuous data, not for discrete data. Don't apply on the discrete data. Scaling should not be applied on the discrete data. Right? Now here, import pandas as PD, matplotlib. Now once it is done, now you are going to read the CSV file, again Titanic only, same data set. This time I am going to take the age column. Earlier I have worked on the fair column. Now this time I am going to work on the age column. Let us see, is there any missing values? Oh, 177 are there. Now I am going to fill these missing values by using the median. Already I have told you how to fill NA, and I am going to fill with the median value. And now the missing values has been cleared off. Now for this, I am going to apply the first one called as standardization. So standardization process, I am going to do by using the pandas or sklearn. By using pandas or sklearn, you can do anything. Here I am going to apply on the sklearn. So in the sklearn, what I have told you, 3 steps. What are the 3 steps? First one is import. Second one is save that one. Third one is fit and transform. Same thing. From sklearn.preprocessing, this is available in the pre-processing module. This is the library name and this is the module name. In that, standard scalar is the function which I am going to import. And this one I am going to save in the name as SC. The function, whatever the function is there, this function I am going to save in the SC. And for the SC, I am going to apply the fit and transform on the age. So if you check, so it is converted. Every value is converted. Is that clear? Is that clear? If you want me to explain in a simple way, I will try with one more example with in the Excel sheet. Okay, let us try in the Excel sheet one more example. Okay, in the Excel sheet, let us take some X values, whatever X values. Tell me of your choice, any 5 or 6 values of your choice, anything. But any one member. One member, you tell me anything of your choice, whether it is plus, minus, or plus, any value, as per your choice, completely. Yeah, anyone. Who wants to say? Example only, Amma. Any values. 10 point. First one is 10. Second one is 0.9. Third one is, tell me 5 or 6 minimum. Here, at least Gopi Krishna is very fast. I'll go with Gopi Krishna. 12, 54, 18, minus 25, super, 10.5. Okay, he has given me these 5 values. Now using these 5 values, I want to convert every value to corresponding z-score. How I am going to convert? First, for these 5 values, I am going to calculate the mean value. How I am going to calculate the mean value? Here I am having with respect to auto sum. I am going to apply the sum of from these 5 values. I am going to calculate the sum, and whatever the sum I have got, divided by 5. I am going to apply 5, which is average. That is 13.9. This is the average value. So I can directly even show the average. Directly you can take the average function. And you can select this one. If what is the problem if I show in the Excel sheet means, you'll ask again to explain the Excel. Okay, again if I want to explain Excel means I have to start from so much of things and I have to end so much of things. And again this course is going to be again 1.5 months. So that is the reason I'm not showing generally in the Excel. Okay, so now mean value is ready. Similarly, standard deviation. How to calculate the standard deviation? STD. Standard deviation value of population or sample. So here I am going to consider the population data and I am going to apply this one. Standard deviation is ready. Now for each value, first this is the first value, value minus this is the 13.9 divided by whatever the divide by 25.11255. So first this is the value minus this value. So x minus mu divided by sigma. So this is the corresponding z-score. For this value, this is the corresponding z-score. Similarly, for this value, this is the corresponding z-score. That is A3 minus 13.9. A3 means 54. If you want clearly miss, you can write even this one only. No need to write A2 also. 12. You write 12 only. 12 minus 13.9. Similarly, this one. 54 minus 13.9. Again, next one is this. 18 minus. Next one is this. That is minus 25. Next one is this one is 10.5. Like this, for each and every value you are going to convert. For each and every value you are converting and you are going to get the corresponding, this is the z-scores. Now, this is the original value. Originally, in the given data, these are the 5 values you have given. Now I am going to convert to these values. Earlier, this is having with respect to values of between 10, means 2 numbers are there. Now everything I have bought between very less values. Scaling I have done. This conversion is called as standardization. Converting the given value to corresponding z-score is called as standardization. That's it. It is going to apply whatever I have done now. The same thing will be applied in the backend code of the standard scalar function. This function was in this backend. What is the backend code of this function is the same. First, it is going to calculate for this particular column the mean. First, it is going to calculate df dot age dot mean. It is going to calculate. After that, for the same column, it is going to calculate for df of age dot standard deviation. These two values it is going to calculate. After calculating these two values, it is going to calculate for in given age column. For in df of age, for each value, it is going to apply the corresponding z-score and it is going to create a list. That list will be converted as a data frame. And that data frame will be added. Now here the age of underscore SC, because this is a new column, it is added as a new column. If I ask with respect to age miss, if I keep this one as age miss, automatically it is going to replace the original one because it is a mutable object. It will replace the original one. Is that clear? Now like this, you are going to convert to the corresponding z-scores. Every value is converted to corresponding z-score. Sir, you can show me directly, you can load the simplify, take some example. And in that example, you can take with some randomly 5 values in the Excel sheet and you can load that one only. Na? Why you are taking this much of big data of Titanic and why you are showing all these things for us, miss? If I show that example, then if I share you the Titanic data set and if I ask to work, miss, at the end of the course, what you will say? Sir has not trained on any case study, just he has given only simple examples, he will say. Now, based on this, what you are going to say? I have worked on the multiple case studies. Right? That is the only one. Simple. So we are going to work on the, just calculate. Manually also you calculate. The same thing you are going to get. How to calculate manually? Can anyone tell me the same manual calculation and how to create a new column? This is standard scalar. Using the standard scalar function which is available in the sklearn. Without using sklearn, I want the same column. Don't use sklearn, but I want the same column with same values. Is your assignment. Not assignment. This is small example on homework. We'll keep it as homework. Okay. Assignment means somewhat bigger task is called as assignment. This is a very small task. Simple example. Anything. Don't use sklearn, I told. Anything as per your choice apart from sklearn. Pandas, NumPy, Core Python, as per your choice. Anything. But don't use sklearn. Using sklearn, I have shown you now. Other than this, you try anything. Out of those two, which is better? You tell me. Which is better means that you continue. Simple. Whatever it is. Okay. And tomorrow I'll tell the answer. Right. Next one is you are going to go with that min-max scaler. Next scaling technique is called as min-max scaling. What is meant by min-max scaling? Min-max scaling is nothing but, for example, this is very simple. We can write very clearly here itself. 1, 2, 3, 4, 5. In this, what is the minimum value and what is the maximum value? Minimum is 1 and maximum is 5. So for every value, x minus x min divided by x max minus x min is the formula. So for the first one, 1 minus 1 divided by 5 minus 1, which is equal to 0. Second one, 2 minus 1 divided by 5 minus 1. Only x value changes. Remaining 3 values will be fixed. This one is fixed, this is fixed, this is fixed. Every time this is only going to change. 2 minus 1 divided by, that is 1 by 4, which is 0.25. 3 minus 1 divided by 5 minus 1, that is 2 divided by 4, which is 0.5. Next one is 4 minus 1 divided by 5 minus 1, which is 3 by 4, which is 0.75. 5 minus 1 divided by 5 minus 1, that is 4 by 4, which is equal to 1. So before min-max scaling, this is the original data. After min-max scaling, now this value will be 0, 0.25, 0.5, 0.75 and 1. Conversion, you have converted. Scale down. This is called as min-max scaler. Right? Min-max scaler. Sadhana is saying that last assignment answers are still pending. So that one also we'll see. What is last assignment? BMI is the last assignment. Huh? First and last. Okay. Fine. Let us see. Okay. So this is with respect to, like this, you are going to convert the data. Data conversion. This is min-max scaler. Okay. So the min-max scaling, the minimum value is going to be 0 and the maximum value is going to be 1. Every value will lie between 0 to 1 only. You are going to get only the positive values. No negative values is possible after conversion. So for example, in my original data, there is minimum minus values are there. Like earlier, whatever the Gopal has given me, Gopi Krishna. Gopi Krishna has given me that 12, 54, 18, minus 25, 10.5. So now just in this also, I am going to calculate the minimum value. What is the minimum value? Minus 25. What is the maximum value? 54. Not 78, it is 18. Okay. So 54 is the maximum value. Now in this case, just you are going to apply x minus, that is 12 minus 25, that is minus of minus 25 divided by 54 minus of minus 25. And you are going to calculate. Similarly for the next value, next value. So wherever the minimum value is there, that minimum value will be converted as 0. Wherever the maximum value is there, that value will be converted as 1. Why, sir? Because x minus x min divided by x max minus x min. Wherever the minimum value is there, x is the minimum value. X min minus x min, what will happen? Automatically 0 only, right? X max minus x min is automatically it is going to be 0. Whenever the x value comes as minimum value, at this position, the value is going to be 0. Whenever this portion is going to be the maximum value, x max minus x min divided by x max minus x min, which is equal to 1. So wherever the maximum value is there, at that portion it is going to be the 1. Wherever the minimum value is there, that portion will be equal to 0. So this is the interview question. What would be the range of min-max scaler? Min-max scaling formula everyone will understand because easy now. But they'll forget what is the range. That is the interview question. It is going to be 0 to 1. So the values is going to be from 0 to 1. Sir, for various G-scores, negative values are also possible. Negative G-scores are also possible. Positive G-scores possible, negative G-scores are possible. Right? Next one is, see, just how you are going to do from sklearn.pre-processing. import minmax scalar. Earlier we have imported standard scalar. Now we are going to import the minmax scalar. Instead of standard scalar, you are importing minmax scalar. Again, you are going to store the same thing in a function name, some function name. As per your choice, you can write it as a function, some name. And you are going to apply fit and transform. And now if you see, this is the original value, this is the standard scalar values, this is the minmax scalar values. For this one also you tell me apart from scalar. Write the code apart from scalar. Okay. So indirectly you are writing the what is the backend code of minmax scalar only. I'm asking what is the backend code of this function. Def minmax scalar. Like this they have created. The person was created like this. And he has written. He is going to return me the pandas. Some pandas data frame he is going to return. Now what is the code they have written in between? That I am asking you. I am asking that one. What is the code behind that? Okay. Yeah. That is one type of scaling technique and this is one type of scaling technique. And which type of scaling technique which we are going to use is during the machine learning algorithms, we will see that one. For which algorithm, which scaling technique we have to use and why we have to use that one only. The reason behind that. That we'll understand during the machine learning algorithms, each of them. Just a standard scaling only. Scaling only. One more scaling also. One more is there. Robust scalar is there. This is also scaling only. Each of them is going to scale only. Earlier I have told you, 80 is there. 80 out of 100. If you divide by 10 if you take numerator divide by 10, denominator also divide by 10 means you are going to get 8 by 10. If you have divided 80 by 20 and 100 by 20 means 4 by 5. If you have divided by 80 divided by 100 and you are dividing 100 by 100 means 0.8 divided by 1. Everything are scaling only, right? With what you are going to divide is the difference. Everything are same. Getting the point now? Same. Like this, we are now the question is when we are going to apply which one is the question. I have shown you like these options. Which one you have to apply when? That is the question. So that question will be seen during the machine learning. So before moving to the advanced level, first we are completing the basic parts. Still we are in the basic one. Okay. Next one is robust scalar. The robust scalar, every x value will be converted to x minus x median divided by median value. Earlier we have done in the standard scalar x minus mu, that is mean value. Now this time we are going to minus by median value divided by IQR, that is Q3 minus Q1. Right? Every x value will be converted to x minus x median divided by IQR. Is called as robust scalar. So here I am going to take from sklearn.preprocessing, I am going to import robust scalar. And this robust scalar, I am going to save it as a function name called as RS. And RS.fit and transform on the edge. And you are going to get like this. This is one type of scaling, this is one type of scaling, and this is one type of scaling. Robust scalar is applying the formula of this one. Next one is called as max app scaling. This is one more scaling, last scaling technique, fourth one, final one. Okay, from sklearn.preprocessing, you are going to import max app scalar. And you are going to save it as MAS, some function name. Every time 3 steps, remember, fix, import, save it, fit and transform. Okay, and you are going to apply the fit and transform and you are going to see. Now, what is the formula for this? Means every value will be divided to the maximum value. For example, if you are having 1, 2, 3, 4, 5, you have to convert this one. Every value divide by maximum value. Whatever the maximum value in the entire data is there, divide with that. If negative value is there or positive value is there, whatever it is, you divide with that. In this case, the maximum value is going to be 1. The minimum value is going to be minus infinite. The range is going to be from minus infinite to 1. Okay. So for example, in this case, in the same example, you have got minus 200, minus 400 also is there. minus 400 divided by maximum value, minus 200 divided by maximum value. Whatever the maximum value is there, every value you have to divide with the maximum value. Is that clear? So the total 4 scaling techniques. What are the 4 total scaling techniques? The first one is standardization. Standardization, the function name is called as standard scalar is the function name. In your notes, you have to write like this. Standardization is function name is standard scalar. And the formula is every x value will be converted to x minus mu divided by sigma, which is G score. X value will be converted like this. Next one is min-max scalar. Min-max scaling. Technique name is called as min-max scaling technique. Function name is called as min-max scalar. Is the function name. And in this case, the every x value will be converted to x minus x min divided by x max minus x min. Next one is called as robust scalar. Okay, robust scaling, and the function name is called as robust scalar is the function name. And in this case, the x value will be converted. Every x value will be converted as x minus x median. First, it is going to calculate the median value of that x minus median value divided by IQR. Similarly, the fourth one is max abs scaling. Max abs scaling. Abs means absolute value. Maximum absolute value. Okay, x divided by x max. What are the maximum values there? Absolute maximum value. Done? Simple. Which one we are going to apply where? That we'll see in the later stage. Clear, guys? Max abs scalar is nothing but just Gopi Krishna. Max abs scalar is nothing but you are going to divide with the maximum value. Divya Rani Singh, that is robust scaling formula is nothing but x value, every x value minus its median value. Instead of going with mean, go with median. Instead of going denominator in the standard deviation, go with the IQR. The only difference between standard scalar and this one is x minus mean divided by standard deviation is the standard scaling, minus median divided by IQR is the robust scaling. That is the difference between these two. You can. Which is not having any impact, any value you can use. If you try with minus 400 miss, you can't try with more minus, the impact will have, right? So the small value, if you are adding or removing, which is having no impact, any value you can add. As per your choice. Which is having no impact. It should not impact the original one. Clear, guys? Yeah. So tomorrow we are going to complete the balance part. Like encoding, how to convert the text data to numerical data. That we'll see tomorrow. Practice, practice, practice.